Right. How are you guys? I hope you are all fine out there. Right. So again, Mr. Samkote taking you for IT grade 10. We are working on repetitions or loops. That is the topic which we are on. We are still on today. Right. Before I proceed, I just want to share with you this book, which is very important, which you can make use of. Okay, this is the book from, it's written Information Technology, grade 10, from the Department of Education, together, sponsored by MTN, okay? So if this is a very important book for your practical, there's a theory one as well. It's a very important book. If you need this book, you can send me your email. You send me your email on this email, lsamukute@yahoo.com. That's my email. You can send me an email there, then I can forward you the two books, the practical one and the theory one. Okay. All right, let's get into today's business. Today, we are looking into the repeat loop. Last week, remember, we were working with the for loop. We did a lot of examples there. Today, we are moving on to the second loop, which you call the repeat until loop. Okay, what does it do? A repeat until loop is test at the end of a loop block. That means one iteration is always executed before the condition is tested. The repeat until loop is called a post-conditional loop because it checks whether it should continue running at the end of each loop. Okay, so you see that this is the structure or the syntax. We've got to repeat, then the lines of code to be repeated here, right, will be there. Then until, then the condition will be at the end. So we call it a post condition because the condition is being checked after the execution. Even if the condition is false, it doesn't qualify. At least to execute once. Okay, so it execute at least once. Okay, because even if the condition is not met, it will at least execute. Then it will check after executing. Right. So that is the for loop. We are going to do a simple example. Right. Before we go into this example, I just want to prove what I'm saying here, what I'm trying to explain, that it will execute at least once, even if the condition is not true. Okay, I'll take you to Delphi. Right. I've got this button in this form there, already prepared. But I'm going to the code block. Okay, I'll just save a variable. Maybe I can say I count, that's the name of the variable, I count, data type integer, right. Then I will initialize I count to, let's say I count this goes to 5, equals to maybe 5, right. Then from there, I'll put my repeat loop. So I'm repeat, say repeat. What are we repeating? Right. I'll repeat, let's say I'll write something on the read output. Right, dot lines, dot 8. All right, I'm going to say hello world. Right. So the condition here, I'm going to say hello world only if I count is not equal to 5. Right. As long as I count is not equal to 5. Right. There we go. So what we are going to see is this code will run at least once. Okay. So I'll run the program here. Right. I'm sure I can share the screen with you. Yeah. So, right, you see there, I'm executing, sorry. I'll execute it, just wait my program, right, let me just stop my program here. Then I'll just make some few changes here. All right. There we go. But I'm just sorry there. I'm just trying to share the screen and make some amendments. So I'm saying it will repeat until, let's say, I count is until I count is what? Let me increment I count here. Let me just have an incrementation of I count. Of I count. So here I'm going to say until I count is less than 5, because we know that I count is already less than. Actually, what happens is like the loop sometimes don't end. Like what because that condition will be never met. If I say I count not equals not equal I count not equal to 5, it means the loop won't end, because the value of the loop will be won't be met at all. Right. So I'll leave that one just because of that issue, meaning that the loop cannot run because it not end because that condition will never be met. Okay. Right. Let's go into today's business. Looking at this example here, which we have to implement. If you look at this example, we've got I count, which is an integer. We begin I count is equals to 0.5. Then our repeat condition is there. What are we repeating? Right. What are we repeating is to increment I count by 0.5. So we'll repeat this code of incrementing I count by 0.5 until the value of I count is greater than 9.5. Okay, until the value of I count is more than 1.5. Okay, I'll take you back to Delphi there. Here we go. Right, so let me take this one off. I count, okay, we've got I count, of course. We initialize I count to 0.5. Initializing I count to 0.5. Yes. Then we are going to increment I count equals to I count plus the question says I count plus 0.5. So we are going to keep on incrementing I count with 0.5. Right. we might need to see the results there so that we can see what values is our I count going to write. Okay, let's see if these values written there. So I'll be writing the value of I count as it loops through. Okay, of course I have to convert it from int to string, str, int to string, I count. Okay, then the condition is saying until I count is greater than 9.5. 9.5. Right. So when I count is 9.5, then our loop stops. But it will stop after writing that value, you will see. Right. I'll run this. There are some errors there. Double termination. What is the other one? Right. There's okay. My comma is taking this instead of the one with the colon is taking this read output dot lines dot head. Right, then this one is also taking this. And what is happening now? Okay, it's not taking neither of those things. Right, let me see what's the issue here. Right. And declare a variable I count, initialize I count to 0.5. We repeat, incrementing I count until I count is less than, actually until I count is greater than, the moment I count is greater than what this, they need to stop, not less than. And let me see again. What is this? What is happening here? Okay, remember my I count I said in integers, not an integer, it's a real actually, is it? It's a real number, please. Yes, yeah, I'm just used to say I count is always an count. Okay, it's a real number. Right. Okay, let's see now. Again, a float to string here. That float to string. Right. But if I run my program, let me share with you the output screen. So if I run my program, these are the results which I'm getting. Okay, let's look at the results. Okay, as one, add another 0.5, we add, let's see where it is ending. Okay, right, you can see that it's ending at 10. That's the number is ending at. Why? Because we said it will check the condition after execution. So by the time it has 9.5, okay, it will again check, okay, still not satisfied, then it will print a 9, then it will check, it will print a 10. After printing a 10, that's when it goes on to check the what? The condition. Is it? Then it will see now it's a 10, then it stops, but it will stop after writing after writing the result, because the condition is being checked at the end of the loop. Okay, so we are saying the condition is being checked at the end of the loop. So because by the time say okay it's 9.5, okay, it loops, then it will write, it will loop, then it will check, okay, it's 10, so I'm stopping it there. Okay, because when it has got 9.5 is not greater than what I count is equal. So it will still proceed to loop again, then it will print a 10 this time, then it will check the condition, then it will see, no, this condition is no longer met. Right, so we call them this name there, So we call them, that's why we are saying here, a repeat loop, a repeat until loop is test at the end of the loop block. This means one iteration is always executed before the condition is tested. The repeat until loop is called post-conditional loop because it checks whether it should continue running at the end of the loop. Okay, right. So this one done. Let's try to do this next one. Right. This one is saying, create a Delphi application to help your younger brother practice his maths. You want to start with multiplication only. He is young, so you decide that the largest product in his timetable, should be 50. Right. When the times table button is clicked, an input box asks the user which table must be displayed. Use a repeat until loop that will stop when the product exceeds 50. Right. So here's the example of the output. So it will ask the user which timetable do you want to do. Right. If the user enters a 5, for example, it will mean that it will display this 5 times 1, which is 5, 2 times 5 is 10. It continues like that until the product, this product is what? It's 50. Right. So if it gets to 50, then it will stop. So we are saying it will stop when the product exceeds 50. At the moment it exceeds 50, then it stops. Okay. So we are going to do this one together. Right. Switch to my Delphi there. There we go. It's a new project which I'm going to open. Right, on my desktop, I've built the interface already. Right. So there we go. Right, this is what we have. Right, so we go there. Right, so what we have to do, we have to declare a variable. Maybe it's iCount, which will track the number of listed timetable, right? Then we initialize our iCount maybe to 0, just to start to 0. Right. Right now we can have our repeat until. We can have our repeat. Then the other until will come there. Right. Now we are going to ask the user to enter whatever the multiplication timetable they want. If they want a multiplication of 5, 6, 8, as long their product, the multiplication table product doesn't exceed 50. Okay, so I will get the input. Let me just have a variable, another variable here to enter the. I can call it inum. This variable will allow. Okay, let me put that, get the input there. Inum will allow the user to input a number which they want. So I'm converting string to int. Remember, we were using the input box last time. So I'm saying I can say the label must be multiplication table. Right. Then the second parameter, which is the user prompt, I can say enter the multiplication a timetable number, right? It's a bit long though, it's fine, okay. Then I'll close it, right? So get our input from the user. How many times? Okay, I forgot to put input box there, please. So you have to put input box, then you open. That's how an input box works. Right. So since our multiplication timetable, according to this screen, is starting from 1. So this is our I count. This will be the values of I count, please. Then multiply by what? Whatever the user would have entered here. Okay, right. So there I come. I increment my I count because I want it to start at 1, not at 0. Right, I'll increment it. Then from there, I'm now saying having a variable, a product. So to keep the product of the two numbers, so I'm having I product. So my product, I product, I'll get it by saying I count multiplied by whatever the user will input, I num. Whatever the user will input, which is I num. Okay. Right. So after that, I have to display the I count multiplied by I num, then equal to the product, which will be returned by this line of code here. Right. So I'm now saying, displaying in my rich edit dot lines dot add. Right. So I'm saying now I want int 2 str I count. Right. Plus we are concatenating. What is between is a star multiplication plus int to string again 2 str. What are we having here? It's I num. Right. Plus the quote equal sign, then plus, then int 2 str I product. Right. Okay. Right. This is int to string. Right. So right, I have this. This is how it is going to be displayed. But now I have to come to my condition there. My condition is that it must do this. It must repeat this until our I product is they said until the I product is greater than what? 50. When the I product is greater than 50. If I say greater than 50, you'll see that it will go even if it's 51. So you say until it's greater than, okay, let's leave it like that. To still work greater than or equal to, you may put greater than or equal to 50, it's okay. Right, so here we go. Right, so let's run it and see how it works. Then we can have a further explanation. Right. I'm switching to the output screen. This is our screen, guys. Right, I'll enter there to ask me for the number. Maybe I want a timetable of 5. I'll say this. Can you see that it's giving me timetable of 5? It's giving me a timetable of 5. Right. Right. What if I put a different number? I can even put a different number. Maybe a timetable of 6. Right. Can you see there? It's giving me a timetable of 6, but look at this one, because by the time it stops, it would have displayed the next number, which is already above 50, because it's checking the condition after execution. It's checking the condition after the execution. That's where this function, this repeat until function differ from other loops. Look at the other loops. Of course, we've used the for loop. For loop doesn't behave as a repeat until, because a for loop you to check the condition before execution, but this one will check the condition at the end. Right. Let's check other values. I can put a 10. Right. It's showing me that. Okay, let's go back to the code so that we can again if refresher look. Okay, so what we're doing is I've got the variable I count, which is a variable which is going to accumulate from maybe 1 to whatever next line our condition is met. So I get the input here for the, this is the multiplication timetable which you want. You select the, put any number of your choice. But then we repeat. Here we are incrementing I count. Here we initialize it 0. Now when you increment there, it will start from 1. Okay, to start from 1. So now it's going to say I product is equals to 1 multiplied by, if you enter 5, it will say by 5. Then it gives you the product, is it? So then we come here, it rises to our rich edit, the value of I count, we concatenate with this multiplication sign, then we concatenate again with the number, which would have entered there. Then we are saying it's equal to whatever the product will be after this calculation here. Okay, then there comes our condition until I product is greater than or equal to 50. Because you'll see, even if I enter a number more than what 50, let's check. But what will happen if I enter, let's say it's asking me for a number, then I enter 1,000 there. Okay, so it will just display one number, 1 multiplied by what? 1,000. To just display one number, which is 1 multiplied by 1,000, because it takes at least once, no matter the condition is not met. Okay, right. Let's go to the next item. The next item, this one is done, is the while loop. While do loop, that's our third loop. Right. The while loop does not necessarily run a specific number of times. Instead, the while loop is a conditional loop like the repeat loop, but it places the condition first before execution. The looping block only before the execution of executing the looping block. Okay, only if the condition is satisfied, the loop body executes. This means that the loop body executes while the condition is true and exits the loop when the condition is false. Right. So the loop is called a preconditional loop, unlike the other one, is it? Which is a post. This is a preconditional loop because the condition that determines whether it is should run is found at the start of the loop. If the condition is true, the loop activates and continues to repeat until the condition is no longer true. If the condition is not met initially, the entire loop is skipped. So this is a direct contrast with the other loop, which is the repeat until loop. Okay, so this one, when the condition is not met, it won't execute at all. Right, let's look at the syntax of this one. Right, there's the syntax. Right, Oh, it's okay. The syntax, for example, let's look at this example. You see that example. Let's see. We are going to use the same example, but in this time around, we are going to use a while loop. Can you see there? We've got our variable I count. We've got a begin. Initialize our I count to 0.5. The while loop, while I count is less than or equal to 9.5, do begin. What are we doing? We are incrementing the value of I count by 0.5. Then we end. Okay, let's execute this and see how it goes. Then we see how it differs with the other one. Okay. Right. So I will still do it here. I will still do it on this one. I'll simply put a button. There's the button, and I'm going to call it just while loop. Right. Let's get started there. We need a variable. We are using var I count, data type integer. Right. Then we come under our begin. We initialize our I count to 0.5. Right. Then we say, put our while loop, while the condition. We are saying while I count is less than or equal to 9.5. 9.5. Right. Then we've got our do. I can see some people here sending red signs. Okay. This is grade 10, but somebody's asking. That's fine. But right, so this is our loop. Then do do begin. Right. So do what? Do begin. We are beginning. What are we beginning to do? Right. We are beginning to do what? To increment I count. I count is equals to I count plus 0.5. 0.5. So we are incrementing by 0.5. Right. Let's save the output so that we can as well see what it's all doing. Right. Dot lines. Dot age. Right. So we are going to display those numbers. Int 2. It's not int, guys. And here you see I'm making the same mistake. It's supposed to be real here. It's not an integer variable, it's real. Right. So our variable is preferably to start with R for real. Is it good naming conventions for variables? So it's R here. Yes, R for real numbers. Right. Of course, it doesn't make any difference, but it's good naming convention to start with. So here I'm saying float to str. Then what am I displaying? R count. Right. So I'm displaying this here. This float to string is right. So I'm going to display the I count there. This time you will see that it won't exceed this figure. It won't exceed it because the condition is being tested before execution. Unlike the repeat until loop where the condition is tested at the bottom after execution. Right, I'm running my program. Yes, this is the output. Right, I'll click here. Then we've got our numbers. Let's just check here. Let's just check where it's ending. 10. Nope, okay. Why 10? It mustn't be 10 here. Let me just check again. Let me go back to the code and try to check the few things here. But here, okay, let me see. So while no, right, I think I made a mistake by putting an equal sign there. That account is equals to account plus account, right, but it's okay now. I think it must be fine now. I was supposed to put less than, not greater than. Less than, not less than, equal to. But let's check again now. I'll run the program again. But I'll click on my while loop. I'll go down and check that. You see that is ending at what? 9.5. It's 9.5. But if it was a repeat until loop, it was going to end at 10. Okay. So this is how a while loop works. This is how it works. Let's go back to the code again, guys, so that you can try to check what we've done. Right, so let's look at it again. Right, let's look at it again. Right, we are saying we have got our account, R account variable. Real variable, we initialized it to 0.5. Then we said while R count is less than 9.5 to begin. Right. Then it's incrementing here. Then it starts to increment our R count by 0.5. Right. Then we display the result, whatever it would have been calculated there. Right. So after writing this, then we'll see our result. Okay. Right. So this is the simpler way of putting using a while loop. Then again, the repeat loop here, we have also used it the same way. Okay. Right. Are we together there, guys? I would want to do the next example, which is this one. Do you mind to try to do this example as well? This one requires you to get a value from an input, integer value from an input box. That then saying while I value is less than or equal to 1,000 to begin, we multiply the value by 2. We change the value by doubling it or multiplying it by 2. Then we display it under the show message. Then we display it under the show message. But the problem with displaying putting the show message inside the loop, it will mean that it will keep on saying show the value until the loop ends. So it will continuously say, it will continuously show you the value until the loop ends, is it? So that's how it is. It will work. Okay. So you if you have got a computer at home, try to implement this in more examples, guys, so that you can see how this loop works. Okay, right. Right. I'll go back again. Please, this book is very important, as I've mentioned. If you need it, you simply send me an email so that I can share the book with you. It's a very important book and very useful book, which you can make use of. Okay. So my email, I'll show you my email now again, so that you see where my email is. Right. That's my email here. So you can get my email, then you send me an email, then I can send you the book so that you can also practice at home and improve yourself. That's it for today, guys. Until we meet again tomorrow. Enjoy.